Hello students, welcome to class 10 math. This channel will be focusing on class 10 math. We'll be discussing the NCERT portions, NCERT textbook sums. We'll be discussing R.D. Sharma sums. We'll be discussing day-to-day real-life applications of the mathematical concepts which we learn in grade 10. And we will also have error analysis. And what is error analysis is basically analyzing our own mistakes from the problems that we have solved so far. So this will be done so that we can improve the areas in which we make mistakes. So right now we'll get started. Right now we are in the month of September. I know September 15th. The board exams are scheduled in February. So I hope this channel will be of great help to students who are currently in your 10th standard. All right, I've come up with a nice topic for today. So the topic, can you guess what could be the topic? So I hope this is something that you've learned this year. Now that is that which is, very hard or very easy, or, some people say, I don't really understand why am I studying this right now, right? So one such topic is what I have chosen for today. Let's get started. So the topic that I have chosen for today's class is why trigonometry in your grade 10. This is only exclusively for students who are in CBSE 2023 to 24. Only for you people I have created this, right? So let's get started. So this is it. Basically, why are we learning trigonometry? This could be the question among most of us, right? We could have this question, right? So all of us have. When I was in grade 10, I also had this question, right? So I feel privileged and fortunate to clarify this with you all, right? Yes, let's get started. So today we will discuss the real life application of trigonometry. At the end of this session, you will be able to understand the use of trigonometry for the professionals, that is by professionals who are using it in daily life. You will also know, how they are using it. And you will also know how you already know how to use it for basic trigonometric functions, right? Today you will be learning how your fundamentals of trigonometry, which is your sine, cos, tan, and the reciprocal ratios, are going to lay the foundation for your future professional degree, or if you want to become a professional, how this basic foundation that you're learning in trigonometry today is going to affect your future. That's something that we are going to learn for today. All right, let's get started. So can you name a person who uses trigonometry every day? Can you name a professional who uses trigonometry every day? Okay. So these people, architects, astronomers, and scientists use trigonometry every day, right? So, and how do they use it, right? These people use it on everyday basis. We are going to learn how do they use it. This is the question that we are going to answer for today. All right. Let's move to the next slide. Do you know trigonometry is used by the following professionals? So trigonometry finds a space or finds a particular usage with archaeologists uses architecture, architects use it, astronomy, people who are with the space science, they use it, Aviation, people are pilots, they use it. Criminology, people who deal with crime scenes, they use it. People who are in the manufacturing industry, they use it. What is manufacturing industries? Big industries which manufacture biscuits, chocolates, cookies, Lays. Yeah, they're all big industries. They also use it. Music, you use it in marine biology, marine engineering, ocean engineering, and also in navigation. And you use it in physics, yes, and in video games. So we are going to learn how is it used. And, we are going to learn that the basics that we have learned today will be useful for us in the future. That's what I said in the beginning of the class. And this is about how is it going to be useful to me. All right, that's it. First point, or the first thing that we are having for discussion right now is trigonometry for your archaeologists. Now, who is an archaeologist? I hope we've learned earlier in our history, right? In your history, when you were in grade 6, they taught you archaeologist. Who is an archaeologist, right? So, yaar archaeologist, they do excavation, right? Excavation panni sites or a heritage site or some kind of a site, right? So they excavate the land and then they dig into the mud and then they have to discover something. So these people use trigonometry in the form of certain instruments. Okay. So earlier they were manually calculating. Today, because of the tech advancement, okay, tech has advanced and they are using this meter called tachometry, where if you can see there are this right angle triangles application, right? So this is something that even civil engineers use it. This is one of their surveying tools. So they use, you can see, when they're constructing metro, you can see people standing on the road and looking at certain things. Civil engineers and other people who are generally using things for constructing, architects, all of these use a particular instrument called tachometry, or this is a particular method actually. All right, so this is a method with which you can calculate the depth at which something is there. You can calculate the type of rock it is, and such things can be calculated. Now, when they are supposed to excavate a particular site, these archaeologists, they will generally divide up, if you give them a particular site to excavate, they will divide the site into many grids or equal divisions or zones. So they will have to divide it like this, and then they will have to do the excavation. And then they can find out at what angle this is there or at what depth it is there. And then they will send it for the further investigation, like how old it is and this. Right? And they have to be very careful. They can't break a particular mummy or a particular artifact that they discover. All right. That's it. Next. Let's go to the next one. Trigonometry in architecture. Yes, this one, I believe we are familiar with this one, right? Why? Because why are we familiar with this one? Because, we can, because we try to, sorry, let me go back to the slides. Architecture, this one is very commonly asked in our public exam, in our notebooks, right? Architects, they are responsible for building any structure that you see. They're not responsible for actually building it. Civil engineers are responsible for, planning it. Civil engineers are responsible for planning and constructing. And constructional engineers, civil engineers and architects generally plan a building, planning, or they plan a building. And there are a group of people called constructional engineers or structural engineers who decide the structure. And then a group of all of these people together, civil engineer, architect, and your structural engineers together, they build structures. Okay. Now they need to have a good mathematical foundation or a basic thing in order to construct so many things, right? If we have to construct a house, we have so many expenses, right? In such a way, you plan a house to have 4 rooms or something like that, that itself you take so much care and you construct, right? Imagine all over Chennai, we are planning for metro project is going on, right? Then what kind of a planning they should have, right? So that's why you see that they're all over the place analyzing each and everything, and then they do. All of these are mathematical calculations. They use certain instruments in your metro project. That is not one engineer who's working. There are many, many people who are working, and they use a lot of instruments. Now, instruments are all based on your trigonometric basic functions. Now, all your instruments are based on the basic trigonometric six types of trigonometric functions that we have studied. And right now you have an instrument called theodolite, which helps you to find the height of a building and all of these. With this instrument, you will get it at the click of a button. But right now you have to learn how to calculate it. Why? Because when the instrument fails, you might have to do manual calculation sometimes. All right. So that's why you need to learn all of these. All right. Yes. So let's go to the next one. Astronomy. Yes, we all are fascinated by space science. Chandrayaan is happening right now, right? Chandrayaan. Chandrayaan has happened. Chandrayaan 3, we have launched. We've launched Aditya L1. All of these space science or astronomy, we need a very basic trigonometric identity calculation. We need to, you need to know the distance between a planet and the sun. All these were done by ancient Indians, especially Bhaskaracharya has told us in Hanuman Chalis. The distance between the sun and the earth is 108 tons. He has made an accurate calculation. Our Indian mathematicians were way ahead than other people. But the only thing is that Indian mathematicians recorded their work in the form of manuscripts, where they didn't publish a particular book or a article, right? So if you want to go into astronomy or space science, then you must definitely be strong in your trigonometry. Why, ma'am? When I become an astronaut, I'm not going to use trigonometry because I'm not going to sit and calculate the machines. You only told, right? The instruments are going to do. Yes, of course, the instruments will do. But if there is a fault in the instrument, if the instrument is not calibrated correctly, how will you find out? You will have to correlate. The instrument is showing me a certain value, but when I calculate, I get a different value, which means there is either problem in your calculation or in the instrument's calculation, and then you will have to check it, right? So our Chandrayaan 1 space mission, right? We had achieved success. In our Chandrayaan 2, we achieved partial success, right? It was partially successful, partially it didn't go as planned. So this partial success was because of something called a rover landed. Vikram rover was there. But what was the cause of this failure of this Chandrayaan 2? It was a decimal calculation error. Can you believe? Simple decimal calculation error has made the has costed us so much. So that's why we ask you to realize the potential of mathematical calculations in a very young age when you are in grade 10. Yes. Next comes an interesting part where we will discuss. Can you see over here the moon is making a 90-degree along with the sun as well as the earth. This happens in the first quarter of your lunar phase. And you can determine the distance between the earth and the sun using this particular relationship. And NASA scientists today are studying and launching space crafts and spaceships just after studying so many things. All right. So let's go to the next one. Aviation is another field which is evolving right now. Aviation refers to, calculating the amount of speed, direction, and distance as well as the direction of wind. So wind is actually a crucial element in flight travel, right? All the time we do not have the same type of wind. Sometimes the winds are very high, sometimes the winds are very low. When you have a storm kind of situation, it's very difficult for the pilot to land, right? Such things. So aviation makes uses of trigonometric relationship in order to calculate whether the flight can land in the right direction, or when will the flight, in which direction should the flight be taken off. All of these things using trigonometry we are doing it. And in your particular, this one, traffic control system, you're using radar, which uses uh, again trigonometry, where they calculate which flight is at which distance and how do they tell whether two flights won't collide using their radar device. Now the question arises, now how do fighter pilots complete their mission? Do they use trigonometry? Yes, because they have a tracking system which exactly uses the trigonometric principles and the trigonometric functions, which helps them sense the nearest object in the form of heat, which is infrared radiation. They use this infrared search and track, IRST system, for, for detecting and fighting against their enemies or any kind of. So fighter planes, if they have to be launched, then we will have to use this particular system, tracking system, with the help of which we can So we have those fighter pilots who complete their mission using trigonometry. And when you become a fighter pilot, imagine you will have access to a beautiful control system of the entire flight or the entire plane, jet plane that you're going to fly. And you must know how to, guess and calculate and get it done, because it's going to be the angle at which you are flying. Everything is going to come up. And the remaining part will come up in the part 2. So wait for it. The remaining part will consist of your, get back, criminology, manufacturing industry, music, marine. The remaining 6 of it will come in the next part. Thank you.